This is the story of a giant machine, forged from steel and built with extraordinary precision to harness the endless power of flowing water. Deep inside this vast iron ore mine, the journey of a giant hydroelectric turbine begins, where ancient rock becomes the foundation of modern engineering. Towering drilling rigs bore deep into the iron ore, creating a precise pattern of blast holes for the controlled extraction that follows. A carefully timed blast fractures the solid rock, exposing millions of tons of iron ore for the next stage of the mining process. Freshly blasted iron ore is carefully loaded into giant haul trucks, beginning its steady journey from the mine toward the processing plant. Carrying hundreds of tons of freshly mined iron ore, the haul truck makes its way toward the primary crusher, where processing begins. The first stage of processing begins as massive crushers reduce the freshly mined iron ore into smaller pieces, ready for further refinement. Powerful conveyor systems carry the crushed iron ore through the processing plant, moving the material steadily toward the next stage of refinement. Powerful vibrating screens separate the crushed iron ore by size, preparing a consistent flow of material for the washing and beneficiation process. Inside the rotating scrubber, powerful streams of water remove clay and surface impurities. This reveals clean iron ore for the next stage.
High-pressure water removes the remaining impurities, leaving clean iron ore ready for the precise separation process that follows.
Inside the hydrocyclones, powerful centrifugal forces separate the valuable iron concentrate from lighter minerals, preparing it for the next stage of refinement. Slowly rotating spiral classifiers separate the remaining fine particles, producing a cleaner iron concentrate before magnetic separation begins. Powerful magnetic drums capture the valuable iron concentrate, separating it from the remaining waste and preparing it for dewatering. Inside the thickener, gravity separates the iron concentrate from the process water, allowing valuable water to be recovered and reused throughout the plant. Vacuum filtration removes the remaining moisture, producing a dense iron concentrate, ready for the final drying process before pellet production begins. Gentle heat removes the final traces of moisture, producing a dry iron concentrate ready for the next stage of pellet production. The dried concentrate is carefully blended with binders and water, creating the ideal mixture for forming strong and uniform iron ore pellets.
Inside the rotating discs, fine iron concentrate gradually forms thousands of perfectly round green pellets, ready for their first quality inspection.
Only perfectly sized green pellets continue forward, while the rest are recycled, ensuring a consistent feed for the hardening furnace.
Inside the induration furnace, intense heat transforms fragile green pellets into strong iron ore pellets, ready for the demanding conditions of steel production.
Controlled cooling hardens the pellets completely, while recovered heat improves efficiency, before the material continues to steel production. The finished pellets are stored, loaded, and transported to the steelworks, where the next stage of their transformation is about to begin. The iron ore pellets arrive at the steelworks, where the journey continues toward one of the most powerful industrial processes on Earth. Iron ore pellets, coke, and limestone are carefully measured before entering the blast furnace, where iron making begins. Layer by layer, iron ore, coke, and limestone enter the blast furnace, where intense heat will soon begin transforming ore into molten iron. Superheated air enters the blast furnace, igniting the coke, generating the intense temperatures needed to transform iron ore into molten iron.
Deep inside the blast furnace, intense heat transforms iron ore into molten iron, while lighter impurities rise to form a protective layer of slag.
The furnace is opened, releasing a continuous stream of molten iron that begins its journey toward the next stage of steel production. The molten iron is carefully transferred into a giant torpedo ladle, carrying its intense heat safely toward the steelmaking process. Molten iron is transferred into the oxygen converter, where recycled steel and pure oxygen will transform it into high-quality steel. Pure oxygen removes unwanted impurities, transforming molten iron into clean, high-quality steel ready for the next stage of production. The refined molten steel is carefully tapped into a ladle, ready for precise adjustment before the final casting process begins. Inside the ladle furnace, electric arcs and carefully measured alloys refine the molten steel. This prepares it for continuous casting. Vacuum refining removes dissolved gases, producing cleaner steel with the strength and consistency required for demanding industrial applications. The refined steel flows into the tundish, where its movement is carefully controlled before the continuous casting process begins. Inside the copper mold, molten steel begins to solidify, forming a strong outer shell while its glowing core continues to flow. Controlled cooling solidifies the steel completely, while powerful rollers guide the strand into a perfectly straight slab ready for cutting. The endless steel strand is cut into precise slabs, ready to begin the next stage of shaping inside the rolling mill. The steel slab is reheated evenly, restoring the temperature needed for the powerful rolling process that follows. High-pressure water cleans the surface before enormous rolling mills begin shaping the glowing steel into its final form. A series of precision rolling mills gradually shapes the glowing steel, producing a perfectly uniform product ready for controlled cooling. Controlled cooling gives the steel its final mechanical properties, preparing it for inspection and the finishing process. Every plate is inspected with precision before being cut to its final length, completing the hot rolling process with remarkable accuracy. After controlled cooling, each steel plate is carefully stacked, ready to begin its transformation into the components of a giant hydroelectric turbine. Precision cutting transforms heavy steel plates into turbine components, preparing each section for machining and fabrication. Each edge is machined with precision, creating the perfect fit needed for the turbine's massive welded structure. Immense hydraulic pressure gradually forms each blade, creating the precise curves that will guide the force of flowing water. Every blade is measured with extreme precision, ensuring a perfect fit before assembly into the giant turbine runner. Each blade is positioned with exceptional precision. This forms the giant runner that will soon convert flowing water into clean electricity. Robotic welding permanently joins each blade to the hub, creating a turbine runner built to withstand decades of continuous operation. Carefully controlled heat relieves internal stresses, ensuring the turbine runner remains strong, stable, and accurate for decades of operation. Precision machining refines the turbine runner, creating perfectly smooth surfaces that maximize efficiency and long-term reliability. 5-axis machining perfects every blade surface, delivering the precision needed for efficient and reliable hydropower generation. Each blade is polished to a flawless finish, maximizing water flow efficiency and preparing the runner for precision balancing. Precision balancing eliminates the smallest vibration, ensuring the turbine runner will rotate smoothly for decades of continuous operation. The turbine runner is joined to its massive main shaft, completing the heart of a machine designed to generate clean energy for generations. The completed turbine is tested under controlled conditions, confirming smooth operation before its journey to the hydroelectric power plant. A protective coating seals every surface, preserving the turbine against years of constant exposure to flowing water.
With manufacturing complete, the giant turbine begins its journey to the hydroelectric dam, where it will soon generate clean energy for millions.
After an extraordinary journey, the giant turbine reaches the hydroelectric dam, ready for its final installation deep inside the powerhouse. Millimeter by millimeter, the giant turbine is lowered into its permanent position, where flowing water will soon bring it to life.
The turbine is connected to its generator, completing the machine that will transform flowing water into clean electrical power.
Water gradually fills the spiral case, preparing the turbine for the moment it begins generating clean, renewable energy. For the first time, flowing water turns the turbine, bringing the entire hydroelectric system quietly to life. Perfect synchronization connects the generator to the grid. Clean hydroelectric power begins flowing across the network. The voltage is increased for efficient transmission, carrying clean hydroelectric power across the grid to millions of homes and industries. Hidden beneath the dam, the turbine works continuously, transforming the river's endless flow into reliable, renewable electricity. From raw steel to flowing water, every step leads here, delivering clean, reliable energy to millions every single day. Hidden within the dam, this remarkable machine quietly transforms the power of water into clean energy, sustaining millions of lives every day. From iron ore beneath the earth to clean energy across the nation, this is the extraordinary journey of a hydroelectric turbine, engineered to serve for generations. You've just witnessed the power and human innovation. Subscribe for more amazing factory stories.